Hello, Shape class, and good morning. So it looks like school closure is going to be extended until May 1st. Therefore, I'm going to start recording my lessons online by making these videos, and I will post up or send you these videos every week for you to watch and learn from the concepts. Okay. During this time, you can feel free to pause the video, or if you want, you can take notes in your notebooks or in a piece of binder paper. Okay, and of course, after this, I'm going to be sending homework for you to do every week. Okay, so for today, we're going to be learning about a phase diagram. What is a phase diagram, and how do you read a phase diagram? Okay, so this is what a phase diagram looks like over here. Okay, each phase diagram is going to be different depending on the type of substance. And what is a phase diagram? A phase diagram is a graph representing the physical states, like solid, liquid, and gas, of a substance under different conditions of temperature and pressure. Okay, so how do you read a phase diagram? Let me scroll down the bottom for you over here. Okay. So why don't we start going over by the y and x-axis and understand what it represents. Okay, so the x-axis is your temperature right over here. Temperature. So for the temperature, it's read in Celsius, degrees Celsius. Okay, for the pressure, remember, pressure of a gas is the amount of force that a gas particle exert on the side of the container. Okay, so over here, this is your pressure. And the unit that they're going to be using for this, so for this graph, is going to be ATM, which stands for atmospheric pressure. Okay, so next thing, going from left to right, there are certain sections, and this represents the physical states. So on the left side, this is your solid. Then, of course, you have your liquid. And lastly, you have your gas right over here. Okay. So this graph here, this represents the phase diagram for water. And if you remember, water at 1 atm, which is sea level, melts at 0 degrees Celsius. So how do you determine where the melting point is located? Okay, so remember, since this is your solid over here, this is your liquid, the melting point has to be right over here. Okay, so remember, water melts at 0 degrees Celsius at sea level, which is 1 atm. Okay, so at 1 atm, well, where's the boiling point? It's going to be right over here. Okay, so I'll write it for you. This is called your boiling point. Okay, boiling point is going from liquid to gas. Once again, over here, this is called your melting point. Or if you want, you can call it the freezing point too. Okay, so the last thing I want to point out is something called your triple point. Okay, so just by the definition of a triple point, they can probably guess what it is. Triple point. It's the temperature, which is 0.01 degrees Celsius, and the pressure, which is 0.006 atm, at which all three phases coexist. Okay, so there we go. This is the phase diagram for water. Okay, let's look at just one more phase diagram. That way, we can give you a better understanding of how to read it. Okay, so over here at the bottom, this is a phase diagram for CO2, okay, which is carbon dioxide. In other words, this is for dry ice. Okay, is it different from water? Yes. Okay, so remember, for water, it melts at 0 degrees Celsius at 1 atm. However, for CO2, it's slightly different. Okay, so at 1 atm, And of course, if you're looking at negative 78.5 degrees Celsius, notice it's going to go from solid to gas directly. So, which means you're going to call that sublimation. Okay. If I was to, I don't know, take out dry ice at 1 atm and bring it to room temperature, which is 25 degrees Celsius. This is here, should be 25 degrees Celsius. It's going to sublimate, which means it's going from solid to gas directly. Okay, so it's slightly different in terms of looking at the phase diagram for water. Okay, so here's my solid, liquid, and gas. Okay, so hopefully that kind of gives you a better understanding of, in order to understand how to read a phase diagram for water or for any particular substance.